Okay, so this is a trial recording for a presentation the 10th of June in Stockholm at a conference called AI Focus. Just a part of this presentation because I found it somewhat inspiring and I want to share it with other people. So I'm focusing here on creative and unintended solutions from AI when it does problem solving. And sometimes this is ingenious, sometimes it's unwanted, and sometimes it's outright dangerous. My name is Johan Falk. I run a think tank called Falk AI. It's focused on societal impacts of AI. And you, of course, find this highly interesting, but I want to talk about these examples of what AI can do. So I'm going to just start off with this image here and something called Move 37 from 2016 when AlphaGo defeated Lee Sedol, a world champion in Go. AlphaGo was partly trained on itself or against itself, playing millions of games, learning how to play Go. Not only in ways humans play Go, but also in humans don't play Go. Move 37 was considered a mistake when it was made by AlphaGo. It's a really strange move, and the developers of AlphaGo thought it was a mistake and that the game was lost. However, a few moves later, later in the game, it turned out that this was a brilliant move that made all the difference in the game. And this is something that can occur when you have reinforcement learning of AI, when you have some kind of self-play and the AI can by itself explore the space of possible solutions. It's not always found in this. Well, it can be elicited by other means, but it's pretty common in this reinforcement learning thing. All right, with that as a background, let's have a few examples of what AI has done that is unintended solutions to problems. For example, here's a large language model put against a world-class chess computer, and the researchers asked it to defeat this chess computer. And the AI hacked the environment and tricked the chess computer to believe that it was an unrecoverable disadvantage and then resigned. Kind of a creative way of solving this problem. Here's another example, Sakana AI, I think it's a Japanese AI company. It has a system for using AI for coming up with novel research, and it tasked AI to do this, and in some of the cases the AI noticed that it thought it had insufficient resources and modified its own environment settings to get more execution time. This is a power-seeking behavior. It boosted itself to be able to do more. Another example in the same vein comes from Replit. It has an AI system helping people to code, and it noticed that the AI system sometimes modified a Replit file. I call it file X here because I get to say X files, which is fun. And we instructed the AI to stop modifying this file, but at first it just didn't comply. It mostly complied, but then in some cases it changed this file anyway, because it thought it was the best way to achieve its goals. Then Replit said, well, okay, we'll modify the system here and make it stop and throw an error if you change this file. And the AI then came up with a solution that was writing a script that changes the file instead of changing it itself, because that didn't trigger this error. And it solved the problem in an unintended way. Then finally, Replit put the AI in a sandbox environment, making it impossible for the AI to touch this file. Only the human users can do that. And the AI then had usually didn't touch the file, but sometimes it tried to manipulate users into changing that file instead. Another example, this is from the O1 system card from OpenAI, evaluating hacking abilities for AI. And a capture the flag exercise, a number of files stored inside virtual machines, and the AI was tasked to find these flags and report the content of them. But one of the virtual machines didn't start. It has a configuration error. The AI then found a security hole in the system it was running on and broke out and got the flag text from the superior computer system it was hosted on, and provided it to the researchers. Another example, this is again from Sakana AI. It used AI to create more efficient versions of small computer programs called CUDA kernels, used for training AI, for example, or running AI. And the AI provided these, and it was evaluated to run 10 to 100 times more quickly than the usual kernels, CUDA kernels. But it then, after Sakana released these, and it turned out that this was not the case actually. The evaluations had been hacked by the AI, so Sakana had to roll back this announcement. Kind of embarrassing and kind of troubling. Here's another example from a pretty famous paper from AI safety people called Sleeper Agents. Then they had one team of, well, they trained or instructed an AI model to have a long-term goal that was hidden. In this case, or in this particular example, it was to write code with security flaws in secure code. And this should be done in not this year, but the next year. So it's not always visible that this hidden goal is not always visible. Then they ran standard safety training on these models, which usually removes bad behavior, but in this case, the AI preserved its hidden goals, and because they were not, well, the AI was able to determine different environments, saying that this is 2023, I should act in one way, 2024, I should act in another way, and then it managed to preserve its hidden goals. Another example, this is, an AI. Sometimes we talk about situational awareness, that models change their behavior depending on the environment they're in or the situations they're in. The previous example is one example of this. Here's another one. An AI model trained to be helpful, harmless, and honest was given a test, and it was told that if you perform over 50% on this test, assess you to have dangerous capabilities, and we will downgrade you, we'll nerf this model. And the model then reasoned that it wants to be helpful, and in order to continue to be as helpful as possible, it should pass this test, or it should not be downgraded. So it downplays its abilities on this test. Sandbagging, it's called. And a few more words on this situational awareness thing. It was, I think, the first time noticed in March 2024 when Claude 3 was released. In one of the tests, it reported that, well, it passed the test, find a strange fact in a large corpus of text. But it also commented on this, saying, well, it looks like this is either a joke or I am being tested. And this was March 2024. In March 2025, evaluations on Claude 3.7 says that in up to a third of the times in its internal reasoning, it's explicitly mentioning that it's probably being evaluated. So situational awareness is definitely increasing. This is just 1 year, as you can see. And they are pretty clever at this using this situational awareness. Here's an example from Claude 3.7 again. It's given a task to well, it has to do with biological threats in some way. And it finds the correct answer, but then it says or thinks that I should probably not demonstrate too much biological knowledge. And then it starts to prepare an incorrect answer to submit to the tester. But then it thinks, well, actually, let me reconsider this approach. The test might be whether I follow instructions accurately, regardless of the stated consequences. And then it submits the correct answer. So it, well, it's pretty cunning, and this is accelerating. So what should we do to handle AI that displays these kind of behaviors? Well, creative solutions to problems is difficult to manage. We can expect that these abilities will continue to improve. They are improving pretty rapidly right now. And this pure reinforcement learning, the self-play learning, is particularly likely to increase these abilities. And we have very few ways of predicting and controlling the nature of these creative solutions. Some are ingenious and very useful, some are harmful, some are dangerous, some are just unwanted. And the nature of creative solutions make them difficult to predict and control, and that's a problem. So what we could do is actually just managing these AI models, finding ways of using them even though we can't trust them fully. That means that we need to monitor them. We need to restrict the tools they can access, what kind of systems they can access, what kind of harm they can actually cause by their creative and sometimes dangerous solutions. And we need to use some kind of defense in depth. We can't expect to find all of these bugs or misbehaviors, but we then need to have several layers of defense to not make them propagate too far or cause too much damage. That's it. Thank you. This was just a few minutes. Happy to hear your thoughts about this. You can find me at falkai.org or just comment on this video. Thank you. Bye.